Chapter 1 Chemical Reactions and Equations. Introduction. Most of the substance around us undergoes various changes. Some of these changes are temporary, with no new substance being formed. They are called physical changes. In certain other changes, the new substance is formed. Such changes are called chemical changes. These changes are permanent changes. Now let us study about chemical reaction. The process involving in a chemical change is called chemical reactions. So the process involving in a chemical change. Already we know that chemical changes are permanent changes and new substances are formed. So that process involving in this new forming the new substance is called as chemical reactions. Let us continue. During chemical reactions, a rearrangement of atoms takes place between the reacting substances to form new substances, having entirely different properties. Chemical reactions involve breaking of old chemical bonds which exist between the atoms of reacting substances and then making of new chemical bonds between the rearranged atoms of new substances. For example, rusting of iron, the setting of milk into curd, digestion of food, respiration, etc. Now let us study about two terms, reactants and products. In a chemical reaction, reactants are transformed into products. The products thus formed have properties which are entirely different from those of the reactants. So, the substance which take part in a chemical reaction are called reactants. The new substance produced as a result of chemical reaction are called products. So, in a chemical reaction, there are reactants. These reactants react together to form products. These products are having entirely different properties from the reactants. Now let us understand the chemical reactions with the help of few examples. Now let us study the first example. And in your textbook, it is given as activity 1.1, and that explains about burning of magnesium ribbon with the oxygen of air. You can refer the activity. So here, as you can see in the picture, we have to hold magnesium ribbon. Okay, we have to hold the magnesium ribbon using the tongues. This instrument is called as tongue. And here you can see the magnesium ribbon, and magnesium is a metal and nearly like a silver or gray color. Okay, and we need to burn it. For the burning process, we know that we need oxygen. So now this magnesium metal will combine with the oxygen which is present around them, and then we'll get a new substance. As you can see here, after the burning process, this magnesium ribbon entirely it converts into a powder, white color powder, and this white color powder is called as magnesium oxide. Now this is the new substance, and the magnesium and oxygen which is present around them, these two are the reactants. They both react together and the new substance magnesium oxide is formed. Okay, now let us continue the notes. Magnesium is a metal generally available in the form of ribbon. It has shining surface. Due to the attack of moist air, that is coated with the white protective layer of magnesium oxide. So, before burning, we need to clean the magnesium ribbon by rubbing it with sandpaper. And this explanation mainly because in activity 1.1, You can see the first point. Okay, clean a magnesium ribbon about 3 to 4 centimeter long by rubbing it with sandpaper. That reason we have studied just now. Why we have to rub a magnesium ribbon with the sandpaper before burning? The answer is here, because of the moist air. Okay, that air contains oxygen. That oxygen will be already reacting with the magnesium, and it forms one white layer, oxide, magnesium oxide layer upon the magnesium metal. So we have to clean it. We have to remove that magnesium oxide layer, and then we have to burn. To clean, we have to rub it with the sandpaper. Now let us study the observation. Okay. When a magnesium ribbon is heated, it is observed that magnesium burns in the air with a dazzling white flame to form a white powder called magnesium oxide. All these explanations are very important. The flame is a white, very bright white flame, and the new product is magnesium oxide, and the color is white powder is formed. And we'll write like this using the formulas: Mg, magnesium, plus oxygen, okay, O2, it's a molecule, and this O2 from air. Okay, when we heat, it forms MgO, magnesium oxide, and that is white powder. And these two are the reactants we have discussed before, reactants, and this is the product. Okay, this is the new one. And the magnesium oxide has entirely different property than the magnesium as well as from the oxygen. And very important note, okay, remember this: the dazzling or very bright white light given out during the burning of magnesium ribbon is harmful to the eyes. So the magnesium ribbon should be burned by keeping it as far as possible from the eyes. And that's why in activity 1.1, in the beginning it says this activity should be like the students must wear suitable eyeglasses. The reason is, while burning the magnesium ribbon, it produces very bright light. It may harm the eyes, and that's why. Now let us study the second example for chemical reaction, and that is explained in the textbook in activity 1.2. Reaction between lead nitrate and potassium iodide. This lead nitrate as well as potassium iodide both are white color powders. Before the reaction, we have to make it a solution. We know how to make a solution. We need to add water. As you can see, after adding water, both will be colorless solutions. Potassium iodide also colorless, and lead nitrate solution is also colorless. So when we do the experiment, what it forms, we'll see. When potassium iodide solution is added to a solution of lead nitrate, then yellow precipitate of lead iodide is formed. See, here we can see suddenly the color changes has been taken place. Mainly yellow precipitate is formed. Precipitate is nothing but insoluble solid is called as precipitate. Okay, that is formed. Now how to write this in a reaction? Pb is nothing but lead and nitrate. Okay, it is a polyatomic ion. PbNO3 twice. Why we are writing this 2 here? Because the valency of Pb is 2. PbNO3 twice, lead nitrate, and potassium iodide, Ki. When these two are reacted together, we are getting one yellow precipitate. See, this is the precipitate, yellow color, and that is lead iodide, PbI2, plus we'll get one more substance or the product, that is potassium nitrate. These both are colorless colorless, but when we have combined these two, we are getting two new products. In that, one is yellow color precipitate, that is lead iodide, and another one is potassium nitrate, which is colorless. Next we'll go to the example 3. In textbook it is mentioned as activity 1.3, and that activity is about the chemical reaction is between zinc granules and dilute sulfuric acid or hydrochloric acid. Any one of the acid can be taken. Okay, so this picture is also there in the textbook, and this apparatus is called as conical flask. In this conical flask, first we have to take the zinc granules. Again they are gray color. Okay, and then we need to add dilute sulfuric acid or hydrochloric acid. Okay, and immediately we can see some kind of bubbles, okay, upon the zinc granules. You can see here, okay, some bubbles will be formed. That shows the formation of hydrogen gas. Okay, now let us read out this. When zinc granules react with the dilute sulfuric acid or dilute hydrochloric acid, then bubbles of hydrogen gas are formed or produced. If we touch the conical flask with our hand, we find that is somewhat hot. Okay, after when we touch this conical flask after the reaction, it will be hot. Okay, two observation we can see. One gas will be released, that is hydrogen gas is released, and then the temperature will be changed after the reaction, and that can be represented like this. Zinc formula is, or symbol is Zn. So when this Zn reacts with hydrochloric acid, that is mentioned like HCl, and we'll get two new products. When these two reactants are reacting, we'll get two new products. One is zinc chloride, ZnCl2, and hydrogen gas. This arrow mark represent this is a gas. Instead of hydrochloric acid, if we would have taken sulfuric acid, it should be sulfuric. Okay, this is sulfuric. This zinc, when it reacts with the sulfuric acid, H2SO4, then we'll get a new product, that is a zinc sulfate and hydrogen gas. Again, the two reactants are reacting together and we are getting two products. Okay, zinc sulfate and hydrogen gas. Okay, this is sulfuric acid, H2SO4, not hydrochloric acid. Yeah. Now, from these three activities, or from these three examples, we can come to some we can conclude few characteristics of chemical reactions. Let me read out. In a chemical reaction, the substance known as reactants are converted into new substances called products. The conversion of reactants into products in a chemical reaction is often accompanied by some features which can be observed easily. Okay, that means when the reactants are converting into products, few features we can identify or we can see. Okay, those features are, sometime the state may change, like from solid to liquid or from liquid to gas. Okay, state may change, color may change, as like the second activity, correct, yellow precipitate has formed, color may change, or evolution of gas takes place, like the third activity, right? So hydrogen gas is formed. Okay, or change in temperature, again the same activity we can take example 3, right? Temperature may change, or even precipitate will be formed. So if we find any of these changes, probably we can conclude that there is a chemical change has occurred, and that can be called as a chemical reaction. Thank you.